Our story begins with a giant cloud of gas and dust. This isn't just any ordinary cloud, but a massive, sprawling nebula that stretches across the vast expanse of space. Imagine a place where the light from distant stars barely penetrates, casting an ethereal glow on the swirling gases and dust particles. Imagine a cloud so big it could hold thousands of suns. This colossal cloud, known as a molecular cloud, is the birthplace of stars and planets. Within its depths, countless particles of gas and dust float aimlessly, waiting for the right conditions to spark the creation of new celestial bodies. This cloud was cold and dark, drifting through space. Temperatures within these clouds can plummet to just a few degrees above absolute zero, making them some of the coldest places in the universe. Despite the frigid conditions, these clouds are teeming with potential, holding the raw materials needed to create stars, planets, and even life itself. But something happened that changed everything. A dramatic event like a supernova explosion can send shockwaves rippling through the cloud. These shockwaves compress the gas and dust, triggering the process of star formation. Alternatively, the gravitational pull from a nearby passing star or another molecular cloud could disturb the delicate balance within the cloud. Maybe a star exploded nearby, or maybe a giant cloud bumped into our cloud. These cosmic collisions and explosions are not uncommon in the universe and play a crucial role in the life cycle of stars. The energy released from such events can be immense, enough to set off a chain reaction that leads to the birth of new stars. Whatever the cause, the cloud started to collapse in on itself. As gravity took hold, the once diffuse cloud began to condense, pulling the gas and dust particles closer together. This process, known as gravitational collapse, is the first step in the formation of a new star system. As the cloud collapsed, it got hotter and started to spin faster and faster. The conservation of angular momentum caused the cloud to flatten into a spinning disk, with the central region becoming increasingly dense and hot. This central core would eventually ignite to form a new star, while the surrounding material would coalesce to form planets, moons, and other celestial objects. This spinning cloud is where our solar system was born. Over millions of years, the particles within the disk collided and stuck together, gradually building up into larger and larger bodies. These planetesimals would continue to grow, eventually forming the planets, moons, and other objects that make up our solar system today. Scientists call this the nebula hypothesis. This theory provides a comprehensive explanation for the formation of our solar system, from the initial collapse of the molecular cloud to the development of the sun and planets. It is supported by a wealth of observational evidence and computer simulations, making it the most widely accepted model for solar system formation. It's the best explanation we have for how our sun, planets, and everything else came to be. By studying the nebula hypothesis, scientists can gain insights into the processes that shape not only our solar system, but also the countless other star systems scattered throughout the universe. This understanding helps us appreciate the complex and dynamic nature of the cosmos and our place within it.
At the center of the spinning cloud, things were getting really hot. The gas and dust were squeezed together so tightly that atoms began to fuse. This fusion released enormous amounts of energy. Boom! Our sun was born. The sun's powerful gravity kept pulling in more and more gas and dust. It grew bigger and brighter, eventually becoming the star we know and love today.
While the sun was forming, the rest of the cloud was still spinning. The spinning cloud flattened out into a disk around the sun. We call this the protoplanetary disk. It's where the planets formed. Inside this disk, tiny particles of dust and ice were bumping into each other. Over millions of years, these particles stuck together, growing bigger and bigger. They formed larger and larger objects, planetesimals, then protoplanets, and finally, planets.
Not all planets are the same. Close to the sun where it was hot, only rocky materials could survive. These materials came together to form the inner, rocky planets, Mercury, Venus, Earth, and Mars. Farther away from the sun, it was much colder. Here, huge amounts of gas and ice could also clump together. These formed the outer gas giant planets, Jupiter, Saturn, Uranus, and Neptune.
Section 5. Moons, asteroids, and comets. The solar system is more than just planets and the sun. It is a vast and dynamic place, filled with a variety of celestial bodies that each play a unique role in the cosmic dance. Beyond the 8 major planets and the central star, the Sun, there are countless other objects that contribute to the complexity and beauty of our solar system. It's also full of moons, asteroids, and comets. These objects, though smaller than planets, have fascinating characteristics and histories that make them worthy of study. They provide clues about the formation and evolution of the solar system. Moons are like smaller planets that orbit the larger planets. They come in various sizes and compositions, from rocky bodies to icy worlds. Some moons have atmospheres, volcanic activity, or even subsurface oceans, making them intriguing targets for exploration. Some planets have many moons, like Jupiter, which boasts 79 known moons, including the 4 large Galilean moons, Io, Europa, Ganymede, and Callisto. Each of these moons has unique features, such as Io's intense volcanic activity and Europa's potential subsurface ocean, while others have only a few or none at all. For instance, Mars has 2 small moons, Phobos and Deimos, while Earth has just one, our familiar moon, which has been a source of wonder and inspiration for humanity for millennia. Asteroids are rocky bodies that orbit the Sun. They are remnants from the early solar system, providing a glimpse into the building blocks of planets. Most asteroids are found in the asteroid belt between Mars and Jupiter, but they can also be found throughout the solar system. They are much smaller than planets and are often called minor planets. Some asteroids are rich in metals, while others are composed of carbon-rich materials. Studying asteroids can help us understand the conditions of the early solar system and the processes that led to the formation of planets. Comets are icy bodies that also orbit the Sun. They are often described as dirty snowballs because they are composed of ice, dust, and rocky material. Comets originate from the outer regions of the solar system, such as the Kuiper Belt and the Oort cloud. When they get close to the Sun, their ice vaporizes, creating a beautiful tail. This tail always points away from the Sun due to the solar wind. The study of comets can provide insights into the early solar system and the origins of water and organic molecules on Earth.
Section 6. The Asteroid Belt and the Kuiper Belt. In this section, we will explore 2 fascinating regions of our solar system that are teeming with celestial objects. Most of the asteroids in our solar system are found in a region between Mars and Jupiter called the Asteroid Belt. This vast expanse is home to millions of asteroids, ranging in size from tiny pebbles to massive rocks that are hundreds of kilometers in diameter. Think of it like a giant cosmic highway with millions of rocky travelers. These asteroids are remnants from the early solar system, offering us clues about its formation and evolution. They orbit the Sun in a relatively stable manner, creating a bustling yet orderly celestial neighborhood. Beyond Neptune, there's another region called the Kuiper Belt. This distant area is even more intriguing, as it stretches from the orbit of Neptune at about 30 astronomical units, AU, to approximately 55 AU from the Sun. It's like the asteroid belt, but much larger and made up mostly of icy objects instead of rocky ones. These icy bodies, known as Kuiper Belt objects, KBOs, include dwarf planets, comets, and other small solar system bodies. The Kuiper Belt is a treasure trove of information about the outer solar system. Pluto, which was once considered the 9th planet, is located in the Kuiper Belt. This dwarf planet, along with its moons, provides valuable insights into the characteristics and dynamics of KBOs. The discovery of Pluto and other similar objects has revolutionized our understanding of the solar system's architecture. The Kuiper Belt is also the source of many short-period comets, which have orbits that bring them close to the Sun more frequently than their long-period counterparts from the distant Oort cloud. These comets, with their spectacular tails, are a reminder of the dynamic and ever-changing nature of our solar system. Space missions, such as NASA's New Horizons, have provided us with unprecedented views and data from these distant regions. By studying the asteroid belt and the Kuiper Belt, scientists hope to unlock the secrets of our solar system's past and gain a better understanding of its future. Both the asteroid belt and the Kuiper Belt are essential components of our solar system, each offering unique insights into the building blocks of planets and the processes that shaped our cosmic neighborhood. As we continue to explore these regions, we are sure to uncover even more wonders and mysteries of the universe.
Section 7. Earth. The Goldilocks planet, our planet Earth, is a very special place. It orbits the Sun in a region called the Goldilocks zone. This means Earth is just the right distance from the Sun, not too hot and not too cold. This just right temperature allows liquid water to exist on Earth's surface. Liquid water is essential for life as we know it.
Section 8. Life in the solar system. As far as we know, Earth is the only place in our solar system with life, but scientists are searching for signs of life on other worlds, like Mars and some of Jupiter's and Saturn's moons. The discovery of life beyond Earth would be one of the most significant discoveries in human history. It would change our understanding of our place in the universe.
Section 9. The story continues. The formation of our solar system is an amazing story, full of cosmic collisions, swirling clouds, and the birth of stars and planets. And this is just the beginning. The solar system is constantly changing and evolving. Asteroids collide, comets streak through the darkness, and planets continue their dance around the Sun.
Section 10. Our cosmic address. We live on a planet orbiting a star in a galaxy full of stars. And our galaxy is just one of billions of galaxies in the universe. The universe is vast and mysterious, and there's still so much we don't know. But by studying our own solar system, we can learn more about the universe around us and our place within it. Our cosmic journey is just beginning.